Hi everyone, I welcome you all to this last part of the lecture, and now I am going to derive the efficiency of the Carnot engine. Okay, so I am going to derive the efficiency of the Carnot engine. So in order to derive the efficiency of the Carnot engine, in any efficiency, what we want is net amount of work done by the engine divided by the total heat supplied to the engine. Heat supplied. Okay, so we are having 4 cycles in Carnot engine: isothermal expansion, adiabatic expansion, isothermal compression, adiabatic compression. And for all of that, we will be going to calculate the work, and we will sum them up, and we will get the total work done. Okay, so starting from the first part of the cycle, that is isothermal expansion. In this part, it is going from initial P1, V1, T1 to P2, V2, T2. The process is isothermal in nature, therefore delta U1, I am calling this process to be first part, that is delta U1 should be 0, because delta T is 0. Okay, so net work done is net work done is N R, there is no change in temperature, NR T1 ln V2 by V1, and that is also a Q1. That is the amount of heat given to the system, and that is why this work is happening, and that is there. So whatever the heat you are supplying, it is converted into this first cycle of the process, and that is what we call, that is Q1. Okay, then we have adiabatic expansion. So in case of adiabatic expansion, it is going from P2, V2, T1 to P3, V3, T2. So there is a net change in heat, that is Q is 0. There is no heat is transferred. Whatever the change in energy, it is because of the work done in order to change in temperature from T1 to T2. Okay, so net work done is W2 is NR T2 minus T1 divided by 1 minus gamma, and because Q is 0, so delta U is nothing but minus of W, and that is minus NR. So that is delta U2, T2 minus T1 divided by 1 minus gamma. Okay, I am also writing for this case P1 V1 is equals to P2 V2. In this case, P2 V2 power gamma is equals to P3 V3 to the power gamma. That is second equation. Now let's look at the third part, that is isothermal compression. So in isothermal compression, it is going from P3 V3 T2 to P4 V4, and because it's isothermal process, again temperature is remains T2, so delta T is 0, means delta U3 is 0, and net work done is nRT2 ln V3 by V4. Okay, so that is W3. This is W2 and this is W1. Okay, the last part of the process is, that is adiabatic compression. In this process, that is third process, in this process we are going from P4 V4 T2 to P1 V1 and T1. So there is a change in temperature as well. For this case, P3 V3 is equals to P4 V4, that is third equation, and for this case P4 V4 to the power gamma is equals to P1 V1 to the power gamma, that is fourth, and the network here is nR T2 minus T1 divided by 1 minus gamma. Sorry, T1 minus T2, right? Because final temperature is T2, T1. So that is T1 minus T2, and delta U4 is minus of W4, that is minus nR T1 minus T2 divided by 1 minus gamma. Okay, so now in order to calculate the efficiency, first we have to sum up all the work, that is, so efficiency is nothing but W1 plus W2 plus W3 plus W4 divided by the total heat supplied, that is Q1. Okay, so W1 is nRT1 ln V2 by V1 and nRT1 ln V2 by V1 plus, if you see W2, that is nRT2 minus T1, and W4, that is nRT1 minus T2, they are exactly equal and opposite, so therefore W2 will cancel W4 because W2 is minus of W4. Okay, W3 is, we have nRT2 ln V3 by V4, and that is divided by Q1, that is again nRT1 ln V2 by V1. So neta, so eta, so I am saying here eta becomes 1 plus T2 by T1 ln V3 by V4 divided by ln V2 by V1. Okay, so we want to find out the relation between V3 V4 and V2 V1, and in order to do that, what we'll do multiply RHS together RHS and LHS together of equation RHS and LHS together of equation 1, 2, 3, 4. Okay, so what we'll get is, so P1 V1 P2 V2 gamma, so we'll get P1 P2 P3 P4 into V1 V2 power V1 V1 V3 and V2 V4 to the power gamma. Again here also we will get P1 P2 P3 P4 and V1 V3 to the power gamma and V2 V4, and from here we can get V1 V3 to the power 1 minus gamma to be equals to V2 V4 to the power 1 minus gamma, and therefore what we get is V1 V2 by V1 V3 is equals to V2 V4 and V2 by V1 is equals to V3 by V4. Okay, so the error is here. So because the finally we are going to V4, so we are writing this, so it should be minus sign will be there come, and we are having minus sign, so because minus nRT2 ln V3 by V4, because we are taking V correct, if you change the sign it will go V4 to V3, and so V2 by V1 is V3 V4. Therefore substituting this expression, let's call it as equation 5 and call it as equation 6. So substituting equation 6 in equation 5, we get neta to be 1 minus T2 by T1. Okay, and that is the efficiency of the Carnot engine. And no engine can have an efficiency greater than Carnot engine. Okay, so I think it's done with the thermodynamics of physics class 12th. So we have discussed Carnot heat engine, we have discussed second law of thermodynamics, we have discussed heat engine. So I think that's all done. Thank you for your kind attention.